In this video, I hope to describe how to calculate the percent composition of the elements in a compound using the example of magnesium carbonate, this MgCO3 example. So what is magnesium carbonate? Just a quick Google search here. It's a chemical, it's a pill that some people take, it's a mineral, and if you don't have enough magnesium in your blood, then your doctor might say, here, take magnesium carbonate. What does it look like? It's this white powdery stuff. And so, again, my goal is to figure out how much of this magnesium carbonate is magnesium, how much of it is carbon, and how much of it is oxygen, because those are the three elements that make it up: magnesium, carbon, and oxygen. And just by looking at this chemical formula here, we see that nobody writes this little 1 here. We don't do that. But we see we've got one magnesium atom, we've got one carbon atom, and it looks like we've got 3 oxygen atoms. So every particle of magnesium carbonate has one of these, and 3 of these. So if I want to figure out the percent composition, I need to figure out the total mass of the MgCO3 first. So I'm going to go to a periodic table, and I have one open right here. It's a pretty nice one. If I mouse over Mg, it says 24.305. I'm going to go out 2 digits here, so I'm going to call that 24.31. So here, 24.31, and that's in grams per mole. And if you heard me use the word mole and that bothers you, you can put that out of your mind for now, because it's not really substantive for understanding what we're after here. If we go to carbon, carbon from that same table is 12.01 grams, and then oxygen is 15.999. I'm going to round that to 16, but don't forget I've got to multiply it by 3 because I've got 3 of them. So 16 times 3 is 48. So if I want to sum those up, I get out my calculator and I put in 24.31 plus 12.01 plus 48. I wind up with 84.32 grams. So 84.32 grams. So now I've got to kind of shift gears sideways a little bit. I told you this was about percent composition. So percent, what does percent mean? We've talked about percent before in this class. Percent is a shorthand way of saying for every 100. Or if you wanted to say it as a fraction, you could say some number over 100. Remember the is over of trick from way back in the fall? Anyway, what we're going to do is we're going to take this fraction and we're going to say we want to think of this as like our 100. So what I want to do here is I'm going to say that my 100 is comparable to my 84.32, and then I'm going to put in my different elements. I feel like I'm talking in circles a little bit here. If I get really bad, I might start over and reshoot this video, but for now I'm going to soldier on. So basically what I'm doing here is I'm kind of pretending that my 84.32 grams is kind of like something out of 100. So that way, if I put a number in here, like maybe for magnesium, carbon, or oxygen, then I will get the percent out of 100 that that element composes in the compound. So let me just stop talking about that and start doing a little bit of math. So what I want to do then is I'm going to say that I'm looking for magnesium. Let's say I want to know my percent composition of magnesium. So I've got 24.31 out of the total of 84.32 is magnesium. So I want to know what this percent is out of 100. And if you don't like percent, then if you wanted to, you could call it, I don't know, you could call it X if you wanted to. So let's do some cross multiplying here. If we cross multiply, I'm probably going to lose my orange here, huh? Yep. So if I cross multiply this and this, I get 2431, because that's 24.31 times 100, and that equals 84.32x. So if I just get my calculator out here, and I want to get rid of this multiplied 84.32, so I'm going to divide both sides by 84.32, and I get 28.83. So 28.83% of magnesium carbonate is magnesium. Okay? And how did I do that? Basically, all I did, step by step, was one, I'm going to make my paper really ugly here, but one, I figured out how much each component weighed from the periodic table. Remember, I had to multiply this one by 3 because I had 3 oxygens here. I figured out my total mass for magnesium carbonate, and then I went to my, remember my is over of trick here, and I plugged in the number for magnesium right there. This was our x, and I cross multiplied, and I wound up with this number. So I'm going to pause the video and I'm going to solve it for the other two really quickly, and then I'll be right back. Okay, so through the magic of pausing, I'm back. So if I want to know the percent by mass of carbon, right here is where I did my problem. I said x over 100, and x is going to be my percent of carbon. And I took my carbon number up here, which was 12.01, and I put that right here, and I compared that, I divided that by the total, which was our 84.32. When I cross-multiplied, I wound up with 14 and just about 1/4%. And then for the oxygen, I did the same thing. For oxygen, it was x over 100 equals, and this time it was 48, remember this 48 right here, over 84.32. And after I cross-multiplied and divided, I got 56.93%. You might be thinking, at least I hope you're thinking, if I add up this number and this original number we got from magnesium, what should they all add up to? Well, let's see here, 28.83, that's basically 29 plus 15, so 39, 40, 41, that's like 43, and then 56.93, that's basically 57. So 57 plus 43, what do you get? You know, I left the decimals off because I'm kind of in a hurry. You get 100%. And that should make sense because all the math we did, we were basically saying, yeah, we want a percent here, so that's why we were dividing by this 100 in our is over of trick. So that is how you figure out percent composition by mass for an element or elements in a compound.